Okay, welcome to the first presentation in Module 5, titled Theory of Markets. Our previous modules have been on the supply side and the demand side. So while we're not talking about what we might normally consider the theory of markets, we're basically going to go through how does GTAP reconcile those two sides in a market system, determine prices, balance out the purchase and supply side, and maintain the full set of equilibrium conditions. Okay, let's start by thinking about the sets in GTAP. We've looked at these before, particularly in our data segments or data focused discussions. Here are all the sets used in GTAP, and they become important for thinking about how are we going to write equations to pair up the supply and demand side of a market and have those balance conditions imposed. And what is going to be critical for us are these two, the margin commodities and non-margin commodities. We'll explain the difference in those. We need to think about activities versus commodities. Okay, remember, producers operate as activities. They do a production system. Now, multiple commodities could come out of that. Commodities are where we're going to see the market purchases made over commodities. And so there could be two producers selling the same commodity. A bunch of purchasers don't really care where it came from. They just buy it, at least on the domestic version of that. And so commodity and activities, margin and non-margin are separations of commodities. We'll talk about that in a second. Derived demand commodities, DEMD, another place we're going to see showing up in some market clearing. This is the full set of things that firms can purchase. And then we need market clearing on the factor markets. And so this DEMD, the part in endowments, is going to be important there. And so we'll have to come up with market clearing equations, or we'll actually not do it here. It'll be later in the phase 2 of the course. You'll start thinking more deeply about this. But there's so many sets because we have to be able to accommodate different sort of balance conditions. So a basic mobile endowment where any sector, the factor could be supplied to any sector, is different than a sluggish endowment where there's additional costs to moving between sectors, and which could allow for prices to differentiate depending on who you're supplying to. And then of course we have some sets for the capital endowment, and then we even have sector-specific endowments. And so there's only one sector to supply to, and so the price determination can only be made between the supplier and demander. So a lot going on in the sets. A lot of the set structure in this model is built to give you these sort of intuitive ways of splitting up equations, because as we've learned in our training here, we want to be able to do analyze GE, and so the analysis for a mobile endowment will look different than a sluggish endowment. So trying to write these equations to accommodate those doesn't make sense because we want to look at them separately anyway. Okay, let's make our way through this. So at the top here we have activities and commodities. And let's just, we'll certainly have more to talk about this in phase 2 of the course when a specialist is talking to us about when the appropriate times to have separate activities and commodities or multi-production, multi-activity, multi-commodity activities, might be. But for now, we're just going to say that activities and commodities are one-to-one matchup. If you're a sector, you're basically defined by the single commodity you make and no other sectors making your commodity. We call that a diagonal make matrix. and then we end up with a 1-to-1, and so activities just pass over to commodities. Now, for our purposes, thinking about the market clearing equations, that's fine. This is the transference or the translation of activities to commodities is really a production side story, and we've already said we're leaving that as an advanced topic for the later stage of the course. The commodities are where we have market clearing, and so it is the case that we have two separate types of commodities. Now, one of these is called the margin commodities, the other is called the non-margin, and the difference here is fairly simple, and we'll see it more clearly in later slides where we have the equations. But margin commodities are those commodities that could be sold to international transport. Okay, now the way GTAP is going to treat this, again in an advanced topic, is going to treat the trade margin, right? So you sell a good, you have to transport it somewhere outside of the country. If you're selling it for trade, then there's some cost margin above the domestic production cost that has to be added to that in this equilibrium system. And so some of the domestic commodities will be supplied to this service of moving things from the source country to the destination country. And so we need to account for the fact that some of the market clearing or the balance has to account for things that are just sold to end users and things that are sold into this sort of external transport market. Okay, and so that's why the margin commodities are separated from the non-margin commodities. Non-margin commodity can be sold to a domestic end user, can be sold to a foreign end user. A margin commodity, and we'll see again in the equation later, a margin commodity can be sold to the domestic end user, the foreign end user, or that transportation service sector, which will have a combination of different regions bundling their services together to make for this transportation network. And that'll include the actual shipping, the port work, the certifications, insurance, all of those sort of things. And then down here we see the endowments split out. So endowments are indexed with an E, and you see the mobile versus sluggish. Let's just focus on those two for right now. And the fact that you've already seen through some of the exercises, been exposed to a little bit of what sluggish factor supply looks like. You'll get more of that as we move forward in the second advanced topics during the intensive second phase of the course. But yeah, we would need separate. So a mobile endowment has a single factor price that clears the market. A sluggish endowment moves with friction, moves with sluggishness between uses, and so you'll get multiple supply prices that balance out so that the average factor price on the purchase side balances up to the supply side. Since we'll be looking at a few equations, let's just remind ourselves of the set mapping in our model, and keep in mind that this is what we call a 3x3 example. 3 regions, 3 commodities. GTAP, these are the hard code names for things: region, commodity, endowment, derived demands. When you take a database, a GTAP database, and you import it for modeling, you might get one that has these 3 regions: Sub-Saharan Africa, EU, and rest of the world. But you may get one that has the US, Mexico, Canada, and the rest of the world. You may get one that has all this other stuff. The stuff in the red brackets here doesn't really matter to us if we're just reading the equations and looking at the sets. These are just the ways this particular aggregation of the database right here has been populated. And so while we teach mainly from the Sub-Saharan Africa, EU, rest of the world, as you continue in your training, we'll expose you to a couple others to give you a flavor of that. And certainly when you get to the final course project phase, you'll be looking at very different aggregations. And so let's keep it in mind that food manufacturer services, we're dealing with a very aggregate version of what we're after here. The endowments, land, labor, capital, and natural resources. And then if you take the commodities plus the endowments, you get everything that a firm or a sector might want to purchase. Okay, so this is the derived demand. Okay, here is the core theory on equilibrium, market clearing, I guess it would be the better way to say it, in GTAP. So you have a domestic supply up here. In value terms, that's called VCB over commodities for the region. And then you get some component of that VDB, that's the domestic version of purchases of the commodity within a region. And remember these B's, VCB, VDB, those are at basic prices. Those are at the market clearing price. Now this is just this branch to this side is just direct sales. So we have the supplier putting something on the market, and then firms, households, government, or investment, the domestic versions of these make a purchase for it. So there's no intermediaries here, right? There's market clearing between the supply to the domestic demand. So that means even though we've discussed margins already, those are folded into the pricing system or the values that are already there. So to the extent that there is some margin costs, they're tacked on to the production side. Okay, they're in the production accounts. So we don't have explicit margin use between final sales and production side, even though it's potentially very important. And there have been certainly some specialized GTAP models to go in to look at those domestic margins. Some of you may actually have already been exposed to some of that data. It's difficult work, and there just isn't the data to populate that at a global scale, just like the sort of government accounts we've talked about before in this first phase module. There's a great will and a great need to have those government account linkages to the government purchases. There just isn't a database to draw upon, particularly one that can be regularly updated and monitored. So, I mean, it's not just the fact of getting a static snapshot of the economy. GTAP is an ongoing database project. That means every 2 years we need a new database that brings forward in time what we have, and so that coverage becomes an issue. Okay, so this branch, pretty easy to identify, again, all at basic prices. Going to this side, the alternative from the domestic sales, supply can be sold in the domestic market. It can also go into the export market. And so here you would see export sales to Sub-Saharan Africa, EU, or rest of the world. These are all trade things, so we're not going to talk about them much. But those are the three destinations. And we could have export sales to what we call the international transport margins. Okay. I'm not going to talk about the trade side, except to note, because it's sort of a precursor and an early question that people have. When you have aggregate regions, you have the potential to export to yourself. And so let's just say the candidate country here that we're looking at the domestic supply and tracing it down the right-hand side, they have a total amount of export sales plus margin sales. Let's say the candidate country here, the exporter, is SSA. Well, they can also make sales to SSA because it's technically an aggregate region. Okay, we're modeling their behavior like they're a domestic economy, but there will be cross-border sales within SSA from two different regions that exist. And so there's no way to zero out. So GTAP has no own trade in the core database at 150 regions or whatever the total is. So USA does not export it to itself in the core database, but if you made a region called North America that had the USA Mexico, Canada, and some territories, then the surviving aggregate database for North America would have trade, and it would be exactly equal to the trade among those three. And so you'd have to account for that as normal effects to be clear with both the pricing system, but the potential taxes that exist between those sales. Okay, so again, it would be in a perfect world we would blank these out, but there's no way to get through this equation and the sort of theory of market clearing at an introductory level even without acknowledging these export sales and the transport margins exist. Focus on these components. So there's sales to firms, to private, government, or investment versions of the household. Okay, so maybe calling this lecture theory was overselling it a bit. It's really an accounting lecture in a lot of ways. And so we're here thinking about our sort of theory of market clearing really just traces its origin back to the accounting. So you've got to have this equilibrium in the initial database, and we don't train in phase one on the GTAP database as a sort of proper entity of construction, but you'll get quite a bit of discussion and material on that in our advanced topics coming up after the online course, and you'll see how the database team works to balance this, what sort of theory impositions they make, what assumptions they have to make, because the initial database needs to represent an equilibrium structure, and so it needs to move from that equilibrium structure to another one, and so it stands to reason it's like going from an initial database that's in equilibrium, shocking it with whatever policies or technology that we want to introduce. We move to a new database that's different than the original but still maintains all the equilibrium conditions we wanted. And those are largely accounting based. They're values that have to, over some summation, add up to the other side of the market. You take all the sellers of something, put them in value terms at common prices, for weights, and then look at all the purchasers. Well, there has to be a purchaser matched up to every sale of a unit and vice versa. And so that's really where the theory comes from. So in the database, total disposition of sales has to balance out against the total purchases at a common price. That accounting structure written in value terms just gives us a map then to the equilibrium structure. So you think about the accounting being the levels form of our equations. And then in GTAP, you've already seen we have a lot of percentage change equations, so we're going to rewrite that equilibrium structure and percentage change and get those changes as variables to understand how the adjustments, it would be one thing to just look at the two databases and compare the level changes, but what we're really interested in is that sort of elasticity or analyze GE type look at where are these, where are the big changes, where are the responses to these shocks. And so really what we're doing is we're going to be linearizing the balance conditions. So we'll start with the value terms, eliminate the prices because they're common, let that give us the level of market clearing equations, and then we'll make it into percentage change. So that'll be our next look in on the slideshow here. Okay. So we have the value of commodity supply here on the left-hand side. So remember what we need. At the same prices, we need a value term on the left-hand side, and it has to be balanced up against, if this is the sales side or the disposition side, then this purchase side has to balance it out, right? It has to hold. Otherwise, we don't have an equilibrium database. And so we can take the initial database, and VCB would be equal to, for any given commodity and region, so the value of commodity sales at basic prices, value of those sold into the domestic market, this is an aggregate over all purchasers, and then the value sold into that transport area, that transport nexus, if you will, that isn't really a domestic sector. It sits out there and facilitates trade between regions, and it is built up from the supply of every region. Okay, so focus here. If we had no transport and no trade, if we were in a Crusoe or autarky, then these two would just balance each other. Everything made is sold domestically, and then these two would just balance each other out. Okay, we're not going to find that in GTAP. So we're going to have this transport, disposition, and trade, which is all the potential export destinations valued at basic prices. Okay, so sum over the destinations. Okay, if these are values, then you could rewrite them as levels variables. The product of levels variables. So a price times a quantity, a price times a quantity, a price times a quantity, and a price times summed up quantity. Okay. If it is the case that these could be written this way, and it is, all right. So these are these are what we would call the domestic supply prices, PDS. So VCB can be written as PDS times QC. All of these could be written with PDS as the price. Then it must be the case that you could divide through by PDS. It's here, it's here, it's here, it's here. It's pre-multiplying everywhere, and be rid of it so that you have a pure commodity levels equation. So quantity levels equation. So this is quantities, the quantity sold domestic, quantity distributed or sent to that transport nexus, and then all of the added up, all the quantities sold to export. This has to balance. This is in the physical, as much as it could be in GTAP. These are the physical units. You would be, the physical units in GTAP are themselves measured in sort of amounts that are worth, right? There are no sort of physical backbone of tons or whatever. You'd have to do some translation for those from using base year data. But there's nothing wrong with saying the initial market price is 1. The quantity then, the price index here is 1. The quantity then is whatever you get when you divide out that price, right? Because we're doing all this in percentage changes, we do not have to be, we can be kind of agnostic to units. I mean, everything here is in relative price terms, so it's not, it's not, the units here are not going to be a problem for us. Okay, we ended our previous slide looking at quantities and levels and how they had to balance. And so we could totally differentiate, right? And so that we're just saying, well, in the old equilibrium, the new equilibrium, these quantities have to balance. And so it must be the case that any change in the total sales, right, the total supply to market of this commodity, delta QC, has to be exactly balanced out by how did the change occur to domestic and then these other two locations, foreign sales and transport. That has to hold, okay? So that difference form of the equation has to hold for both the original and the new databases to maintain the balance condition we already required of it. What can you do after that? Well, once you've got these deltas in, then you're ready to start thinking about proportional change. And so if you divided here by QC, that would make it a proportional change, but the only way to introduce that is to multiply and divide, right? So we need a QC times delta QC over QC, you get proportional change, okay? And if you add a multiple of 100 to that, the proportional change becomes the percentage change. So this now is the percentage change in the quantity sold. This is the percentage change in domestic purchases, percentage change in transport, percentage change in exports by region. So these percentage changes are all valid, right? They're all being divided by, they're all delta QC or delta QDS divided by their own levels. That's a proportionate change. You multiply it by 100 to make a percentage change, and you're left with these pre-multiplying coefficients. So QC is the original level multiplied by the percentage change, right? And that makes sense. That's a completely valid equation. So if you want to get the change in QC to balance off against all of these, one way to do it is to just take the difference. Another way is to take the percentage change multiplied by the original level. Percentage change by the original level. Okay. And then just a notation here that we put in, because this is the first time in this lecture that we've had these lowercase mixed with uppercase. The lowercase are the percentage change variables, and GTAP expects to see it that way, and GTAP is written that way. Okay, so we can finish up sort of our theory and maybe both theory and implementation of how GTAP is written, recognizing that we had a pre-multiplying quantity times a percentage change, a quantity times a percentage change on the previous slide. Now we can do something else. We got rid of a common market price early on, right? We said there was a price, a supply price, or a basic price, the common market price. And if you can look in table 2.8 in the documentation, the journal paper for GTAP version 7. So if we decide to go back in and pre-multiply by that price, then we are bringing back VCB and VDB and VST and VXSB. Now those are the pre-multiplying coefficients. Okay, and why would we want to do that? Well, that is a preliminary step to getting to the actual form that is written into the GTAP model. So now you got a value times a quantity, a value times a quantity. This has to hold, right? Because you can multiply an equation by a common factor, and here it's just the common market price. So every one of these is P times QC, and it has the same price in all of these. And then finally, to get to the share term of the equation, we'll divide everywhere by VCB. Okay, and so when we divide by VCB on this side, we end up with a 1, right? And so it's gone. And so the left-hand side is just going to be the percentage change in the quantity supplied. Now, when you divide by VCB here, you end up with VDB over VCB, and that's just the sale. That's just the share of the supply that is sold into the domestic market. When you divide by VST by VCB, right here, you get the shipping and transport share. Okay, and then when you go here, you get the share to any one destination, VXSB over VCB. Okay, so why does this work? Well, because VCB is equal to VDB plus VST plus the summation over VXSB. So these are all components, right? If you added them up, all versions of them, you would get the left-hand side in values terms. And in fact, that's our starting equation, remember? So we're just bringing back, we brought back the price, now we're bringing back the values. So we need to be able to do the differentiation on just the quantity variables, right? Taking the differences and converting to percentage change. We just brought everything back. And so now we've got a full linearization of our market clearing condition. And you can see all the information we brought back in, because now we have value share weighted right-hand side versus the left-hand side. So how do you think about a percentage change equilibrium equation? The percentage change in the supply must be equal to the share weighted percentage change in all of the demands. Okay, so the share sold to demand multiplied by the percentage change, the share sold to transport by the percentage change, the share sold to exports by the percentage change. Okay, that brings us through a full differentiation. That's how it works. That's how all these market clearing equations are going to look in the model. So we're going to, in later lectures, we'll flash through them And we'll just be expecting, right? If you want to come back to this or come back to the notes and think about linearization, that's fine. But this is the only time we're going to spend time on it in this phase 1 of the course. In phase 2 of the course, we'll do it again just to give some repetition and to look at specifically these other 2 pieces that we just kind of glossed over, and just what does a trade matrix look like, and add to this, what does the transport market look like, and why can we say that there's a common price, in the price linkages when you move outside of the domestic economy. So what sort of additional conditions are being put in place to make that whole? And so that gets us to sort of our end point for thinking through this in theoretical terms, or in sort of how's the design set up. And we expect to see some more market clearing conditions. We expect those are going to be quantity percentage change equations with value shares used as the weights on one side of the equation. So the total sales is share weighted change in all the other sales, in all the purchases. Okay, that'll close out our time on the first presentation of this module. Thank you for your attention, and we do have a quiz for you to look at. And of course, if you have any questions, reach out to the contact available for this course.